copying these notes down.
Or do you want us to name this?
You can name it rectangle. Yeah, I didn't give it a name. So call it rectangle.
No racism for Stop, Austin. Because you're attracted to
Stop.
Can I have this? Have your Robin Are you serious?
Not even joking. Like, not even straight up. Yeah, serious.
Let's
Try it.
see.
It's amazing.
What kind is
Eat
that?
and dry.
Tastes like potatoes.
It's amazing.
I know. That's like what? Potato chips. Those are really good. I might try it.
Yeah, you should.
You say you go dry?
Yeah.
All right, I'm turning the slide here in a second since you guys can't shut up. All right, so we're going to cover rectangles. Last time we talked about this, we're going to fill in this chart for the rest of this chapter. How do you know if something's a quadrilateral?
It has 4 sides, but none of them are anywhere.
Doesn't matter, it has what?
4 sides.
4 sides, that's it. So if you just had to prove something was a quadrilateral, all you'd have to do is count that it has 4 sides. Then we went over 5 ways to prove something was a parallelogram. All right? Well, so we check, see if it's quadrilateral. Well, we don't just stop there and say everything that's got 4 sides is quadrilateral. So sometimes we say it's a parallelogram. If it is a parallelogram, then the next thing we need to check for on that shape is to decide whether it is a rectangle or not. The rectangle is going to be the next branch in this picture here. What we're going to do with rectangles, same thing we did with parallelograms last time. Some problems, they'll tell you it's a rectangle, and then you use the properties to figure out things. Other problems, they'll give you a 4-sided figure, and they'll say, decide whether this is a rectangle or not. And we're going to learn how to prove that it's a rectangle, just like we did last time with parallelograms. All right, this is the definition of rectangles. Rectangle is a quadrilateral with 4 right angles. So a quadrilateral that has 4 right angles. All right, the properties of a rectangle. If we're going down this chart, how many sides did the parallelogram have? 4. It had that same property because it came from quadrilaterals. Guess what's going to be true about the properties of a rectangle?
4 sides.
Has all these properties, and it has all of the properties of a parallelogram. Now, if it just had those properties, would we want to call it a rectangle? No, then it'd be stupid to give it another name. We'd have 2 names for the same shape. So a rectangle has all the properties of a quadrilateral, all the properties of a parallelogram, and it has a few of its own properties. All right? And that's what the first thing here says, is all those properties that we listed last time for a parallelogram also work for a rectangle.
You gotta write them down again.
Yeah. It won't kill you. Let me count up the words. 1, 2, 3, 4, 8, 12, 16, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27 words. If you die for writing 27 words, Damien, I'll drag you out in the hallway so somebody else can deal with it.
All the properties, because you don't have all of them.
Yeah, that's because a couple of them sort of unnecessary for this. So if we have a rectangle, we know opposite sides are parallel. So this side's parallel to this side's parallel to this side. We know opposite sides are congruent, so these two sides are congruent, these two sides are congruent. We know opposite angles are congruent. These two are congruent, these two are congruent. We know consecutive angles, so like angle Q and angle P here must add up to be, what's supplementary mean again?
Add 20.
Two angles that add up to 180. Notice over here, next week we will have a vocab quiz. I might have said something about that last time when we were talking about supplementary, right? Guarantee that it's on there.
No, you said, reflexive.
I said that for reflexive too. Listen to the whole time, Jalen, and you heard me say it for both of those. Consecutive angles are supplementary. So we know that. The diagonals, what did the diagonals of a parallelogram?
They bisect each other.
They bisect each other, so these two parts are the same. These two parts, probably should put probably should put 4 marks on there. These two are the same. Now, in a rectangle, if I could actually draw a rectangle correctly, which I probably can't, look at the diagonals. Last time I probably had somebody walking from here to here, then somebody else walking from here to here. This time, if I had people walking across it, who would walk farther?
Right there.
It'd be the same, all right? So in a rectangle, not only do the diagonals bisect each other, but the diagonals are actually equal to each other. Well, then when I mark these, should these all be marked differently?
No.
No, what's true about all 4 of these little parts?
Very cool.
They're all 4 equal. So instead of marking them differently, in a rectangle, we know that all 4 of these are the same. What's another property of a rectangle that a parallelogram didn't have?
All right angles.
Has all right angles. And that's the next part here. It just tells the 2 properties. These 2 properties are properties that a rectangle didn't have. Or I'm sorry, that a parallelogram didn't have that a rectangle does have. If I see me hit record.
No, I think so.
Think stupid thing disappears and I can't tell whether it's doing it right or not. If you get on Moodle and watch any of these videos to go back through anything, for some reason my sound's not working now. It works like every other time. I don't know why. Gotta figure it out. I know why. They changed my computer and that messed everything up and it's not set right
Why
anymore.
can't you request it back, or did they reformat it?
They probably done
They
something
change
with
your
our,
whole computer, like to give you new monitor or anything?
not a new monitor, but a new tower. They said apparently this one's better, which might be better. It's not better for me because I don't know how to use it. Everything was set up the same on the way I liked it on the other one. So all these properties for a rectangle. So if you know something's a rectangle, you know all this information. Just like last time, If I tell you this is a rectangle, do you want to go through and mark all this information? No, if I tell you like this is 5x, this is 20, and I want you to find x.
X equals 4.
All right, all you want to do is use which one of these properties? Opposite sides are congruent. That's the only one you need for that certain problem. So you got to pick out what you need for each certain problem. What if I told you this right here was 5x plus 10, that angle? Which one would we use? Do we know opposite angles?
Four right angles.
It's got 4 right angles, so what do you know about this angle right here? It's 90 degrees, so our equation could be 5x plus 10 equals 90. Set up that equation, solve it. So only use the properties that you need for that certain problem. Don't try to list them all because it's just too confusing. And as we go farther down this list, what's going to happen with other shapes that are farther down? Are they going to have this many properties? No, they're going to have more, right? And it's just going to keep adding on. All right, way to prove that something is a rectangle. So write this down. Key thing, whenever you're proving any of these shapes, you're just going to go down this chart. Hey, is this a quadrilateral? If yes, then you check to see if it's a parallelogram. If it's a parallelogram, we can't just stop there now. We got to check to see if it's a rectangle. So we prove first that it's a parallelogram. If it is a parallelogram, then we can use one of these 2 ways to show it's a rectangle.
Sorry. What the?
While you're writing this down, a few things listed over here. You might want to read them before you walk out today. Don't forget the vocab, the 9 words off of Moodle. If you didn't get them in yet, get them in. If they're not in by Monday, they won't be accepted. Along with the laws test, if for some reason you haven't turned in your laws test yet, some people were absent and stuff. If it's not in my hand by 7:35 Monday morning, it goes down to 0 and it stays at 0. Binder list is on Moodle. If you get on there under this week, and I'll put it on next week's also, it'll say list of what needs to be in the binder for 4th 9 weeks. You click on it, pops up a piece of paper, shows it to you. You can print it off or write it down or do whatever you need to do. Video and quiz on Moodle. If you haven't done that yet, that was assigned yesterday. It closes down tomorrow. Get on there and do it. Vocab quiz next week. There'll be a vocab quiz early next week. I've already told you a couple of things that's going to be on there for sure. What was one of them? Supplementary angles. What are supplementary angles? 2 angles that add up to equal 180. What's another one I told you?
Complementary. No,
Reflexive property. What's a reflexive property again? Anything equals itself. I think maybe I might have said something about a midpoint. What's a midpoint? Point that splits a segment into 2 equal segments, 2 equal parts.
It's gonna be like the last one. It's like matching.
Nope. Gotta write it down. It's harder for me to grade. If that makes you happier.
It doesn't.
So if we wanted to show something is a parallelogram, if I give you a shape and it's on a coordinate system, remember the easiest way to decide whether this is a parallelogram is probably by using the slopes. You find the slope of this side and the slope of this side. What should be true about those 2 slopes? They should be the same. All right, so if the slope here was 3 over, can't be that. If the slope here was -2/3, the slope down here would have to be what? what has to be true about these two sides? Slopes have to be the same again. So let's say the slope of this one was 3/2, slope of this one was 3/2. We now know that it is a parallelogram. Does that tell us it's a rectangle though? No, to see if it's a rectangle, we need to either show it as a right angle or show the diagonals are equal. Well, we could draw the diagonals in here and find the length of each one of them. That takes too long. Because if you remember this, what's true about those two slopes right there? What are they to each other? Finish it. Opposite reciprocals. Well, if those two are opposite reciprocals, what do we know about that angle right there?
I'm guessing it's 90 degrees.
It's 90 degrees. They're perpendicular, right? If slopes are opposite reciprocals, then the two lines are perpendicular. So right here, you might want to write down somewhere. If slopes are opposite reciprocals, then I'll just use the perpendicular symbol. What's that perpendicular symbol tell us about that angle? 90 degrees. And that'd be enough to say that that would be a right angle, or a triangle, or a rectangle. So if slopes are equal, things are parallel. If slopes are opposite reciprocals, then they form right angles. Alright, draw this, write this problem down. We're going to do this together real quick. Then we will go back and do some problems off the worksheets, which you will turn in today, and do maybe some problems off of next class's assignment. Oh, it's probably smack Chase 'cause he's sleeping. Should be right. All right, notice when I named this, I just wrote rectangle ACDB. There is no symbol for rectangle. So if you see that little symbol, what do you know the shape is? Parallelogram. No matter what other shape it might be, you know at least it's a parallelogram. But that's the only one that we have a symbol for. In rectangle ABCD, AE, that's this segment. Let's write with our pen this time. So from here to here is 2x plus 3. And segment BC, that's fun to mark. So segment BC, this whole diagonal going this way is 6x. How can we set up an equation? Can we set up 6x equals 2x plus 3? Go ahead.
It would be 2x plus 3 equals 3x.
How come 3x?
Well, this is only half. I was trying to think of another way to do it. Like
All right.
2 parentheses 2x plus 3.
You could do that. All right, so there's two different ways you could do it. This part's 2x plus 3. We know the diagonals bisect each other. So this part down here has to be 2x plus 3, correct? We could say 2x plus 3 plus 2x plus 3 equals 6x. Or the way Joseph went through and did it, if this whole thing from B to C is 6x, well, what's each part of it?
3x.
3x, it's half of it, right? So
X
that's
equals
3x,
3.
that's 3x. Then what equation can I set up?
2x plus 3, in which x equals 3.
2x plus 3 what?
3x.
Equals 3x.
X equals 3.
We solve.
Chill out.
Over here, these cancel out, you're left with 3. X equals 3. Is that our answer? Do what?
We are not finished.
So what do you gotta do next?
Plug in x.
Alright, and a lot of people in the chapter 7 test, please remember, in here, if you find X, are you normally done? No, they normally want the angle or a segment or something. You got to remember to go back and plug in. A lot of people wrote this down as their answer on that test. Well, if X equals 3, we want to find the length of segment AD. That's this whole thing. How can we do that?
Okay, 3.
You could plug in 3 in both these spots, right? That'd be sort of silly. There's an easier way. What do you know about the both diagonals?
Oh, you just plug in 3, it'd be 9. Not 9. It's 18.
You plug it in right here and it's going to make it easier than doing all that work, right? What's 6 times 3? 18. So segment AD equals 18. Even though we actually found the length of segment BC, they're both the same, so it's got to be 18 also. Looking at this picture, what can you tell me about, since we know this is a rectangle, what can you tell me about angle CAB?
It's a right angle.
It's a right angle. Tell me an angle that's congruent to angle CAE.
BED.
Say it again.
BED.
C.
Oh, CAE. Oh, I said
CAE.
CAE?
Yep.
Yeah, DB. Wait, no. Huh.
Got the vertex in the wrong spot.
EBD?
Say it one more time.
EBD?
Got the vertex in the wrong spot.
DEB? What?
This angle right here.
I got this.
BDC.
Say it one more time, Joseph.
BDC.
EDB. Yes.
EDB. That one.
What I was saying.
Name me an angle that's equal to or congruent to angle ACB.
CBD.
CBD. That'd be this angle right here.
I said DBC.
What kind of angles are those two angles to each other?
Opposite interior.
Close. Alternate interior. Alright? Name me an angle that's congruent to angle AEB.
CED.
What kind of angles are those two to each other? Vertical angles. You gotta remember all that stuff. What do you know about angle CDB?
It's a right angle.
It's a right angle, so on and so on. So we know all that information about this. What do you know? Name me a segment that's equal to segment AB. CD. Opposite sides have to be equal, right? So make sure you remember all that information. All right, on the worksheet. Get out the worksheets from last time. We're going to go over problems off of it. Make sure your names are on them. You are going to turn them in. Questions, problems you want to see me work off the worksheet?
We only have to have 30 of them done?
30 of them, yep. Questions, problems you want to see me work? 4 on 424? Problem 4 on 424. Can you guys see that? All right, my shape doesn't look like it should look, but it's going to have to do. 30 degrees, this is Y, this is 3X, this is 10. Which one's easiest to find first, X or Y?
X.
X. What's this 3X have to equal?
10, which x equals 3.3.
No, don't tell me that, Joseph. I don't want to hear silly stuff like that. What's
What
x
is it
equal?
supposed to be?
3 over 10, or
I don't want a decimal.
10 over 3.
You could leave it 10 over 3, there's a little better answer than that.
Let's see.
3 is part of the answer.
Can you do 3 1/3?
3 and 1/3, thank you. Why do I not want that decimal answer?
Because it's not good.
You gotta round it off.
Yeah.
Did I have to round off my answer? No. Now to find y, notice this triangle over here. Let's see. I forgot something in here. They told us that was a right angle there. If I split off this triangle, before you say anything, don't say right triangle. What kind of triangle is that triangle? 30, 60, 90. In a 30, 60, 90 triangle, side across from the 30-degree angle should be labeled what?
X.
L. X would be acceptable also. Side across from the 60-degree angle,
X radical 3.
so L radical 3, and side across from the right angle,
2x. L2.
L2 or 2L. We know that this side over here is 10, so what's L? 10.
Radical 3.
Well, if L equals 10, and we're looking for Y, which is this side, all we gotta do is plug in 10 right there, so what's Y equal? 10 radical 3. Alright, so 10 radical 3 and 3 and 1/3 is the two answers. Don't forget, once we learn something and we take a test over it, you're supposed to just forget it forever?
Yeah.
Yeah, make sure you do that. That's all. That way when you get out of school, you've forgotten everything, right? And you wasted 12 years or 13 years of your life for no reason. Next question. No others? Just collect them?
Number 6 on that same page.
Number 6 on that same page. Number 6 on the same page. This one's a little tougher. But you still, if you remember the stuff from the past, it's not that tough. So they give us some shape, sort of looks like that. This is X. Got the diagonals drawn in here. And I know my shape doesn't look very good, but that's 4. This is Y. This is 17. And I think that's everything in it.
Right angle. What page are you on? Yeah, what page?
Last page.
Right angle. X, like.
So right there's a right angle. If that's a right angle, what's this angle up here? Right angle, those are alternate interior. Again, my picture doesn't look like it's drawn correctly, but don't go by that. If I do this, if I split off this triangle right here, what kind of triangle is it? This time you can say it.
Right angle.
It's just a right triangle, correct? We know that this side is X. This right here is 4. What's this part down here? 4. How long is this whole side then? 8. Does everybody see that? Diagonals bisect each other, so if that part's 4, that part's 4, that whole diagonal has to be 8. How about this part right here in that triangle?
17.
That's this part up here. Well, what do we know about opposite sides in a parallelogram? Congruent, so that's 17. Can we find X?
Yes, painfully.
How?
Diagrams
You
theory.
could use Pythagorean's theorem. A squared plus B squared equals C squared. There's an easier way though.
The stuff we learned like last.
Not sine, cosine, tangent. Now, you could do that, that's harder. How about one of the families that we learned when we learned Pythagorean's theorem? Does it fit one of the families?
I bet it does.
I bet it does too. Remember me saying that almost every triangle that they'll show you from here on out will fit a family because they're being lazy and they want to use those over and over again? Now, if you don't remember that, then let's use Pythagorean's theorem. Huh? No, families.
Oh, one of those families.
So,
At bare minimum, X has to be.
what goes in place of A?
8.
8. It's not gonna be funny, might throw you out of here, Jalen.
I'm not
X
laughing at it.
squared.
I don't care who you're laughing at, I just want you to quit.
Or
What goes next?
X squared.
X squared. What goes last? Somebody help me out with your calculator, what is 8 squared?
Square is a squared.
64 plus x squared equals
289.
289. Then what do we do?
Reduce.
Subtract 64, you end up with x squared equals
225.
225. Then what do you do?
Take square root of 225.
Take square root of 225.
That is 15.
So what's x equal?
15.
15. If I could ever get my pen to write. So x equals 15. So we know that this side right here is 15. What's this side over here then? 15. What kind of triangle do we have right here?
Choose.
Right triangle.
Right triangle, even though my picture doesn't look much like it because I didn't draw it very well. That's a right angle. That side's 15, that side's 4. This side over here is y. How could we find y then? Pythagorean's theorem again, right? Tell me how it's set up. What squared? 4 squared is a y.
Nope, it's not 15.
It's the leg, right? 2 legs equals y squared because this time that's the hypotenuse. What is 4 squared? 16. 15 squared, we just did it a second ago. 225 equals y squared. 241 equals y squared. What do we have to do now? Take square root. 241 is probably not a perfect square number, is it? 15.5. So y equals 15.5. So those are our two answers. X equals 15, y equals 15.5. Next question.
Number 5, same page.
Number 5 on the same page. Number 5 on the same page. Wonder if I change colors, if it'll make it show up a little better. What color would show up better on this?
Black.
Red's what I'm using. Black. On number 5, probably some of the same stuff on this one, because what kind of triangles do you have in there again? Right triangles. Yeah, I sort of drew that a little better than the last drawing. I'm not sure why they told you that these two angles were congruent. Should you know that already?
Yeah.
What kind of angles are they? Vertical angles. If this is 3x, what's this angle over here? They also tell us that this one over here is congruent. Well, if that's 3x, what's this? 3x. The one over here is also. We have that triangle right there. 3 angles of a triangle should add up to be how much? 180, so 90 plus 6x should equal 180. That's going to allow us to solve for x. What's 6x equal? Subtract 90 on both sides. 90. Somebody help me out. What's 90 divided by 6? So we know x is 15. Did they give us a y on this one? Did I forget to put in? 2y right there. Probably forgot some other stuff too, didn't I? This is 12. Right. Next thing, we can't find y because we don't know this. Can we just say 2y equals 12? Do those two have to be equal to each other? Not if it's a parallelogram. If it was a rectangle, they would, but not a parallelogram, so we can't use that. But what we can do is use what we just figured out. X equals 15. So what's this angle right here? 15 times 3, which is 45. What's this angle up here then? What's this angle right here then? 45. What's this angle right here then? 45. What's this angle down here have to be then? That has to be 90. So we have this triangle right here on this side. And it's what kind of triangle? And don't say a right triangle. We already used that up. It's a 45, 45, 90 triangle. We know this side is 2y. What's this part down here? 12, because the diagonals bisect each other, right? Well, in a 45, 45, 90 triangle, sides across from the 45-degree angle should be labeled what?
Same.
So L and L, side across from the right angle, L radical 2. What's L equal this time? L equals 12, so in place of L right here, what can we stick in? So that side is 12 radical 2, but they didn't ask us to find the side, they asked us to find y. 12 radical 2 should equal 2y. How do you get y by itself? Divide by 2. If you got 12 radical 2's and you split them up with your neighbor, how many radical 2's each one you're going to have? So 6 radical 2. That's what y is. 6 radical 2. Now, could you have used like sine, cosine, tangent and came up with a decimal answer and all that stuff? Yeah. If you remember the 45, 45, 90, 30, 60, 90, makes it a little easier probably. Other questions? I got time for one more.
Number 5 on the page before that.
Number 5 on the 3rd page. Let's just look at it real quick. Segment LM. Segment LM has to be congruent to what other segment? PN. So you just write PN with the little segment symbol. Don't forget your symbols. I have a lot of people doing this. What is that?
Something.
P. It's nothing that we know of, right? Now what is it? Angle P. Make sure you're putting your symbols in there. I'm going to start marking stuff wrong.
Number 6 on the same page.
Number 6. Number 6. I probably won't do number 6, but what I'll do is just draw the picture and we'll put everything in that we know. This angle's 25, this angle's 30. What's this angle right here then? 25, what's this one? 30. This is 4b minus 1. This over here is 23. What equation can we set up to solve for b? Somebody could solve that and tell us what b is here in a minute if you want. B equals whatever. How much is this whole angle right here? 55. What do you know about consecutive angles in a parallelogram?
They add up
They add up
to 180.
to 180. So 180 minus 55 is how much? 125, is that right?
Yeah.
So what's that whole angle right there? 125. What's this whole angle down here? 125. Should they tell us anything else? It looks like that's about it. That's about all we can find. Anybody find B? No, yes, maybe? Shout out a number, then I'll write it up here.
4,455.
That's right.
So if you write that down, we'll know you listened to Joseph and you're not very bright, probably. Make sure before you go, this with your name on it goes right here on this table. Make sure all this stuff is done next week. Don't forget any of it. Make sure your names are on the papers and they're on the table. Joseph, did you actually finish this?
Yes.
Joseph, are you lying to me?
Yep.
Because I am going to email your mother today, so you might want to rush home and try to erase the email.
Why would I? That's actually a little cry.
Do you know why I'm emailing your mother?
Because I'm not doing as well as I used to do at start as quarter.
Not completed assignments. How do you not complete a take-home test? Why didn't you finish it?
I did.
You skipped the whole back page just about.
I heard the office real quick. Like a pass or anything. I just need that pass.
produced that video.
Oh,
My video.
Really?
Yeah.
Was it that good, Thomas?
I guess.
Then why don't you do that good in my class?
It had a main menu, scene selection.
bloopers.
Step it up in my class.
If we made videos, sure, I could do that, but